All right, so this is day 4, the final day of the fundamental theorem of calculus. And so the first thing I want to talk about is, again, what the fundamental theorem of calculus says, which is this: the integral from a to b of f of x dx equals capital F of b minus capital F of a, where capital F is an antiderivative of f of x. So in other words, if you want to evaluate a definite integral, you take an antiderivative, plug in the bounds, and subtract. All right? That's what we've been using. Really no big deal. What this lesson does is it says, well, what if instead of evaluating the integral, what if your key was saying, well, I want to know the function value, the antiderivative value at a certain point b? Well, if I want to do that, what I can do is take this fundamental theorem of calculus and rearrange it and say f of b equals f of a plus the integral from a to b of f of x dx. And what this really shows us is that the end value, and again, it's not really the end, but an end value of a function is equal to the initial value of the function plus the integral of the derivative of the function. Well, what that really means is if the end value equals the initial value plus the integral of the derivative, and again, I'm saying derivative because we're finding the end value of f and the initial value of f, so we're taking the integral of lowercase f, which is the derivative of capital F. Another way to write this is that our end value equals our initial value plus our net change of our function. Because if I take my initial value plus my net change, that'll tell me where I end up. So again, what that really ends up meaning is that the integral of f prime of x dx from a to b equals the net change of f on the closed interval from a to b. And the reason that makes sense is if you take the integral of velocity, it gives you distance traveled, kind of. It really gives you displacement. The integral of velocity, when we found the area under the velocity curve, it tells us how far we traveled, right? Now, we're going to talk a little bit later about, well, technically the integral of velocity gives you the net change or displacement, because what if some of it was above and below the curve? But in general, your integral of a derivative gives you your net change, all right? So let's talk about this in a couple different contexts here. Find f of 5 if you know that f of 3 is 2 and f prime of x equals e to the x over 2. You may use your calculator. All right, so f of 5 is going to be f of 3 plus the integral from 3 to 5 of f prime of x dx. The value at 5 equals the value that I know about, which happens to be f of 3, plus the integral from 3 to 5 of f prime. My ending value equals the initial value plus the net change on a given interval. So it says I can use my calculator. So f of 5 equals f of 3, which is 2, plus the integral from 3 to 5 of e to the x over 2 dx, because they told me e to the x over 2 is the derivative. So I'm going to pull up my calculator here and see what my calculator says. So my calculator, I'm going to write 2 plus math 9. And again, if you have the new fancy OS, this looks like the integral symbol. If you don't have the fancy operating system, your equation will look slightly different. I will put that up here as well for those of you who are still on the old operating system. So there you go. It's 2 plus the integral from 3 to 5 of e to the x over 2 dx, and that's 17.401. All right, now if you have the old operating system, real quick, I'm going to switch mine back to classic mode. That's the old operating system, so if you have that, wonder if it'll let me second enter. Ooh, it will. If you have that one, it should be 2 plus fn int e to the x over 2, comma x, comma 3, comma 5, integrand, comma x, comma lower bound, comma upper bound. Okie doke. All right. Find f of 1 if you know that f of 7 is negative 4 and f prime is ln x squared plus 1. Okay, fine. So, I know f of 7, I want f of 1. This one, though, I know the end value, I don't know the initial value. So one way to think about it is to say, well, the integral from 1 to 7 of f prime of x dx is going to be f of 7 minus f of 1. Well, if I want to solve for f of 1 equals f of 7 minus the integral from 1 to 7 of f prime of x dx. In other words, your initial value is your end value minus the net change. You just work backwards. Some of you may have been able to do that right off the bat, but basically, if you're ever stuck, you can start at the fundamental theorem and then solve for whatever you need. So in this case, f of 1 equals f of 7 minus the net change. So in my handy-dandy calculator, I am going to do this. I'm going to put it back into math print mode, though, so sorry, those of you who have the old operating system. So on this one, I have, let's see, f of 7, which is negative 4, minus the integral from 1 to 7 of ln x squared plus 1 dx. Negative 19.978. Okay, fine. Any questions? You can't ask me questions because I'm not here. So, haha. But if you have questions, put a little asterisk and ask me when you get to class. All right, now this one's going to be a no calculator. So there's a couple different ways to go about it, and I'll show you some options here. So find f of 2 if you know that f of 1 is 6 and f prime is this. All right, well, f of 2 should be f of 1 plus the integral from 1 to 2 of 3x squared plus 4x minus 1 dx. F of 2 equals f of 1 plus the integral of the derivative. Okay, so your end value is your initial value plus the integral of the derivative. Okay, fine. I can't use my calculator. Well, fine, be that way. F of 1 is 6. To evaluate an integral, you take the antiderivative. So I'm going to add 1 to the power, divide by the new power, add 1 to the power, which is going to make it x squared, divide by the new power, and then that's going to be an x, and I'm supposed to evaluate that from 1 to 2. So I have 6 plus 2 cubed, which is 8, plus 2 times 2 squared minus 2, minus, now I'm going to plug in 1. So I have 6 plus, let's see, 8 plus 8 minus 2 minus 2. So I have 6 plus 8 is 14, plus 8 more is 22, take away 2 is 20, take away 2 is 18. Now that's one way to do it. There's actually what I consider to be an easier way to do this as well. If this is f prime, then f is the antiderivative of this. So the antiderivative of this is add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, minus x plus c. When I take an antiderivative, but I don't have a definite integral, I need to leave behind the plus c. So if f prime equals this guy right here, the 3x squared, then f is this x cubed expression with a plus c at the end. Well, I know that f of 1 is supposed to be 6. So that means this function should equal 6 when x is 1, right? That makes sense. So when f is 1, I should equal 6. Now I can solve for c. And I can say, well, 6 equals 1 plus 2 minus 1 plus c. So this c is going to be 4. So f of x is x cubed plus 2x squared minus x plus 4. So then they want f of 2. F of 2 is 2 cubed plus 2 times 2 squared minus 2 plus 4, which is going to be 8 plus 8 minus 2 plus 4, which is going to be 16, 14, 18. Son of a gun, I got the same thing again. So there's two different options. Option 1 is use the fundamental theorem of calculus and do that the end value is the initial value plus the net change. Option 2 is just find the general antiderivative, use the initial condition, that's what that's called, use the initial condition to solve for c, and then find the value that they're asked for. All right, so let's do another one using one of those methods. Doesn't matter which one. So if I look at this next one, find f of x if you know that f of 3 equals 2. Well, now I'm forced into this method because I want this. I want the antiderivative, given that the derivative equals this and my initial value is f of 3 equals 2. In that case, you're forced into saying, well, I know that f prime is e to the 3x over 2, so then f is the antiderivative of this. All right, so when you take the antiderivative of an exponential, it's going to be the same exponential, and then I'm going to divide by the coefficient of x. So when I go to take the derivative of e to the 3 halves x, it's going to be e to the 3 halves x times 3 halves. So if I put a 2/3 down here, then when I do my times 3 halves that's going to jump down, they'll cancel out so that the derivative is just this guy. All right, so the antiderivative, keep the original, divide by the derivative of the exponent, slap a plus c on there. I know that f of 3 is 2, so 2 equals 2/3 e to the 3 times 3 over 2 plus c. So c is 2 minus 2/3 e to the 9 halves. That's a constant. It's an ugly one, but it's a constant. I can live with that. So f of x is 2/3 e to the 3x over 2 plus 2 minus 2/3 e to the 9 halves. And that right there is f of x. Okay? Now, we can apply this idea to rectilinear motion as well, because I have position, velocity, and acceleration, and all three of those things are just derivatives of one another. So when you see these, by the way, you can use the notations interchangeably. If you want to take s prime, you don't have to write s prime equals v. You can just write v. We're fine with that. So let's see. Find the position function for an object if its velocity is given by this and its initial position is 5. Now, the word initial, you can assume to mean t equals 0. So if you're given something within a context where time is involved, initial is always assumed to be when your time equals 0. All right. So this is telling me, pardon me, look, I'm boring myself. No, I'm not. I love this. Well, if there were logs, I'd love it more, but I still love this. Initial position is 5, so if my velocity, v of t, is 68 minus 20t, and I want my position, I'm going to take the antiderivative of this. So the antiderivative of 68 is 68t. The antiderivative of 20t is add 1 to the power, divide by the new power, plus c. Now, s of 0 is supposed to be 5. So 5 equals 0 minus 0 plus c. C equals 5. So the position function, s of t, is 68t minus 10t squared plus 5. All right, I'm at 14 minutes now. You've been listening to me for 14 minutes. I still want to get through this while we're on the video. So I would like you to pause the video. We've done enough that I think you can try the rest on your own. Pause the video, try the rest on this sheet, and then just press play on the video. I will super duper fast go through it, and then you can be done. So press pause and then come back. Pause, 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 pause. All right, so for number 6, you should have gotten this thing right here. You should have gotten s of t is 5 halves t squared minus t cubed plus 12t plus 18. What you had to do is you had to do an initial value problem twice. So first you start with a of t equals 5 minus 6t. The antiderivative of that is this v of t, 5t minus 3t squared plus c. Since the initial velocity is 12, I set that equal to 12 and plugged in 0 for t and got c equals 12. I substituted that c back in and started over. Here's a velocity equation. I know initial position is 18, so position is this antiderivative. Set that equal to 18, plug in 0 for t. Get another c equals 18, so my position function is 5 half t squared minus t cubed plus 12t plus 18. Next one, same idea, and the key on this one was when I solve for c, the t actually matters a little bit more, so you can't just ignore the 0. So I have a of t equals 4 minus e to the t. The antiderivative of that would be 4t minus e to the t plus c. Now, when I plug in 0 for t, I'm supposed to set it equal to 9. 4t at 0 is 0, but e to the t at 0 is 1. So when you plug in zeros, that doesn't mean that c is always going to equal what your initial value is. You have to actually plug in the initial value and solve for c. So in this case, c equaled 10. And then down here, instead of giving you an initial value, I told you at t equals 3, the position is at negative e cubed. So I plugged 3 in for all of my t's, solved for c, got negative 48. So f of t is 2t squared minus e to the t plus 10t minus 48. What did the pirate say on his 80th birthday? He said, "Aye, matey." Think about it. Oh, it's kind of good. You giggled a little. All right, I'll see you soon.